The frequently asked questions for pre-calculus for P6, starting with number 16. And while I'm writing this problem down, I notice that this isn't simplified because this shouldn't be left as a negative in the radical. So what we should change that to is the square root of 2i. Because remember, when you pull the square root of -1 out of something, in this case we're factoring it out, what you're going to do is create that imaginary number by pulling that out. So now we would do FOIL, and first times first would give us 6 times the square root of 2i. Outside times outside would give us plus 5 square roots of 2i squared, because those both have an I in them. Inside times inside would give us plus 12i. And last times last would give us plus 10i squared. So now we have things to simplify here, because what we need to do is make sure that those I squareds become -1. So we'll go back and make those a -1. And that will give us 6 square roots of 2i minus 5 square roots of 2. Notice that one doesn't have any more I in it because it had I squared, which was -1, plus 12i, and then minus 10. And last but not least, what we have to do is get this in standard form, which means the real parts are out front. So that would be -10 minus 5 square roots of 2, or you could put -5 square roots of 2 minus 10. It just looks nicer to have the radical in the back. And then anything with the imaginary, so that would be plus 12i and plus 6 square roots of 2i. And then what we want to do is put this in that form of a plus bi. So I look at this, and the real part, we could actually just leave it like that. I know the book took a negative out of there, but we could certainly leave that -10 minus 5 square roots of 2. You just want to put parentheses around it so that you can see, hey, that's my A portion, my real portion. And then in the back, we have two things that have an I in them, and that's the 12 and 6 square roots of 2. But you can see now, this is our A, this is our B, and this is our I. And that finishes that problem up. Just kind of a lot to keep track of as you go through that problem. And that's probably what happened to most people, is you just lost track of something. In most cases, probably an I. Number 23 says find the real numbers x and y that make the equation true. And we have 5 minus 2i, that quantity minus 7 equals x minus 3 plus yi. Well, the first thing you have to do is simplify this. And the parentheses on the left aren't really doing anything other than showing us that this was a complex number. And over on the right-hand side, we have to distribute that negative through the parentheses. So on the left-hand side, we can see that the real part would be -2 and then minus 2i. And on the other side, we have this x minus 3 and minus yi. So here's what I know. If this is going to work, this has to equal -2. That's the only way that this is going to be equal. So if x minus 3 equals -2, x will equal 1. And then we go after the y and say, well, that's not tough. This needs to be a 2. So that real part is probably what messed people up here, and that our x minus 3, the real portion of the right-hand side, has to equal the -2 on the left-hand side. All right, now for 30, 31, and 32, what we're doing is we're multiplying by conjugates. So we can see that sum and difference pattern that most often we recognize the other way, which is as the difference of 2 squares when we factor. So when we look at this one, we recognize that we have a plus and a minus because that's the conjugate in between those two terms. You just change the sign in between your real and your imaginary part. And then we don't have to do all of FOIL. All we have to do is first times first and last times last. So first times first is 25. Last times last is -36i squared. So that will be 25 plus 36 because I squared is -1. And then we just go ahead and add those together, and that gives you 61. Then in 31, we have negative 3 plus 4i, so the conjugate would be negative 3 minus 4i. Notice the negative in front, we leave that alone. It is just the sign between the real and imaginary parts that we change. And then it's first times first, negative 3 times negative 3 is 9, last times last, a negative 16i squared, because 4i times a negative 4i will give us a negative 16i squared. And the I squared is a negative 1, so this will become 9 plus 16. And after doing a couple of these, we should realize, wait a minute, it's always going to turn out to be a plus in the middle. And the reason that's going to happen is because if we do a minus b times a plus b, we get a squared minus b squared. But if this includes an I, it's going to change that to a squared plus b squared. All right, let me work this back up. I'll go after 32, which is a negative 1 minus the square root of 2i. And we'll need that to be negative 1 plus the square root of 2i for the conjugate, because again, all we do is change the sign between the two terms. So first times first is going to give us 1, negative 1 times negative 1. And then last times last, our negative square root of 2i times a positive square root of 2i. That will be a negative square root of 4, because the square root of 2 times the square root of 2 is the square root of 4, I squared. But we can simplify both of these, because I squared is negative 1 and the square root of 4 is 2. So this will be 1 minus, and then it's going to be a negative 2, which is 1 plus 2, which is, of course, 3. Next one up is number 36. And this says write it in standard form without using a calculator. So the issue here is that we have that square root of negative 1 in the denominator. And what we want to do is multiply that by the conjugate. And whatever you do to the denominator, you need to do to the numerator. So on the top, we're really going to be distributing a negative 3i times the 2 plus I, which will give us a negative 6i. And then positive I times negative 3i will be a negative 3i squared. And on the bottom, negative 3i times negative 3i will be a negative 9i squared. So we have some simplifying to do here. The I squared is a negative 1. So negative 3 times 1 will give us 3 minus 6i. And that will be over I squared of negative 1. Negative 9 times negative 1 is 9. Now, you might want to go ahead and reduce that right now by a factor of 3. But don't forget to put that in standard form. So here's our real part, 1/3. Here's our imaginary part back here, negative 2/3 I. So just finishing that up by putting that in standard form. Once we get that square root of negative 1 out of the denominator, because that was really kind of the most important part of what we did here. Then 42 and 44. All right, let's see what we've got going on here. So for number 42, we have 3x squared plus x plus 2 equals 0. The first thing we would try is factoring this. So we'd say, okay, factors of 3 in the front, factors of 2 in the back, that would add to give us a positive 1. That's 1 and 2. And we go through this and we see, well, that would be 2 plus 3, that's 5. That's not 1. And this would be 6 plus 1, which is 7. So this isn't factorable. And again, you could take b squared minus 4ac and use that discriminant. If it comes out to be a perfect square, you know you messed up. That is factorable. But it's not. So here's what we're going to do. We're going to solve this by completing the square. I'm going to divide everything by 3 and get x squared plus 1/3 x plus 2/3 equals 0. And then go ahead and move that 2/3 over to the other side, because that is not helpful. It wasn't completing the square for us, so subtract that from both sides. And then you just remember b over 2 squared. And remember, when we divide a fraction by 2, what we're really doing is multiplying it by 1/2. So that will really be 1/6 squared, which is 1 over 36. So we need to add 1 over 36 to both sides. And you see that 36 is going to end up being a really nice denominator for us over here. And this will be x plus 1/6, because remember, that is what we squared to get 1/36. And then that equals, do a little common denominator action over here. We're going to need to multiply by 12 on the top and the bottom. So we get negative 24/36 plus 1/36, which is negative 23/36. Next step, we extract the roots. We take the square root of both sides. So x plus 1/6 equals plus and minus. Well, we know we have an I in there because we have that negative square root of 23, so we factor that out. And then the square root of 23, there's nothing we can do about that prime number, but the square root of 36 is 6. Last but not least, subtract 1/6 from both sides. And we have negative 1/6 plus or minus the square root of 23/6. Again, completing the square, if you're good at it, it just makes a lot more sense than using that quadratic formula and not having any idea whether or not your answer is correct when you get done. All right, 44. We have x squared plus x plus 11 equals 5x minus 8. And again, we're hopeful that maybe, just maybe, this is factorable or something that's a little bit easier. So let's move it all over to one side. We'll subtract 5x from both sides, and we will add 8. And that hope is pretty quickly snuffed out because we take a look at this and realize, 19, it's prime. 1 of 19, there's no way to get a negative 4 out of that. So let's move that bugger over and complete the square. Let's put that negative 19 on the right-hand side. And look at our b over 2 squared, but this time it works out really nice because our b value is negative 4, and negative 4 divided by 2 is negative 2. And when you square that, you get a nice little 4. So we're going to add 4 to both sides. And that will make this a perfect square trinomial, which we will write as a binomial squared, and that one is x minus 2 squared. And then we have a little negative 15 over on the other side. So now we take the square root of both sides, and x minus 2 equals plus or minus. We recognize that that's going to be I. The square root of 15, there's no perfect squares that we can pull out of that. Let me make that more readable there. And then what we need to do is just go ahead and add 2 to both sides. So x equals 2 plus or minus the square root of 15I. And that one is done. And that was the last one that you had for the FAQs.